This is an introduction to the periodic table that you will be using in class. We will be handing this out and making sure that everybody has a copy of this. And you are more than welcome to write on it as I have written on this. So you will be given this on all of your tests, and it's especially useful for naming. Again, the same key characteristics as in any other periodic table. You have your atomic number, which is the number of protons, the symbol for the element, which is always a capital letter, and if it's followed by a capital letter, it's always followed by a lowercase letter. The name of the element and the molar mass, the average molar mass. So a couple things that you need to go ahead and start to color in. So here I have in blue this first column. These are the alkali metals. They take a +1 charge. Alkaline earth metals I have in green. You can have however you want to. These are alkaline earth +2. So my little mnemonic that I have, and I love mnemonics, is that alkali is one word, has +1 charge, it's in the first column. Alkaline earth has 2 words, it's in the second column, it takes a +2 charge. They didn't do that on purpose, it was just a happy circumstance. Then here's the Zental boundary that we talked about. So this is the thing that separates the metals on the left side from the nonmetals on the right side. Above the boron column, this takes a +4 charge. Carbon column takes a +4 charge, +3 for boron, +4 for carbon. Nitrogen just down to the Zental boundary takes a -3 charge. Oxygen column down to the Zental boundary takes a -2 charge. And this column, the halogens, take a -1 charge. So remember that negative charges are only applicable to non-metals. We'll talk about what's going on with boron later on. And these noble gases very rarely react, and they do not form ions, so they just take a 0 charge. The other thing that I have done is I have circled in orange hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And these are elements that in their natural state are found as diatomic compounds. That means that rather than O gas, it's O2 gas. These are things that you are already familiar with, but hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, all when they exist in their natural state by themselves, exist as a diatomic. So it'd be H2, N2, O2, F2, Cl2, Br2, and I2. When they are in compounds, all bets are off. They don't stay diatomic. This is just when they are found by themselves in their natural state. So there are 2 mnemonics for that. We either call them Brinkelhoff, and Brinkelhoff is bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine. Or some people prefer Huckleberry-Finn. Hydrogen, oxygen, chlorine make the Huckle, and the bromine and iodine make the berry, and then the fluorine and the nitrogen make Finn. I prefer Brinkelhoff. It kind of rolls off my tongue more easily. You can use whatever mnemonic you need to, but you are responsible for knowing what the diatomic elements are. Everything in between the alkaline earth metals and the Zental boundary will take a variable charge. There are exceptions, and we will talk about the exceptions. The exception is that silver takes a +1 charge, zinc takes a +2 charge, and aluminum takes a +3 charge. Everything else takes a +2 charge usually, but could take another positive charge depending on the conditions under which the ion is formed. So again, the ones that are non-variable are silver +1, zinc +2, and aluminum +3.